let's take a minute to talk about how we write or come up with differential equations. And this is because we're usually looking to model some situation in the real world or to explain something using a differential equation. So the key vocabulary that we want to talk about is identify the relationship of the rate, or in other words, the derivative, to other factors that show up. So maybe it's related to how high you are, or how quickly something's moving, or whatever it is. But we want to somehow relate that derivative to other factors, come up with an equation for that. So key vocabulary, if something is proportional, that means you should have A is equal to some constant times B. So if A goes up by twice, then B also has to go up by times 2, right? Because they're directly proportional. Inversely proportional, you'd have something like A divided by B equals a constant. Sorry, no, that's not right. It should be A times B is equal to a constant. Or you can write that as A equals a constant divided by B. So if A goes up, B goes down. If B goes up, A goes down. If you want this top one, you can also write this as A over B equals a constant. Because in that case, if A goes up, B also needs to go up to keep the thing constant. Squared, cubed, etc. If they say something like it's proportional to b squared, you're going to have a equals k b squared, that sort of idea. Same thing with square root, cube root, etc. You can have something like a equals k times the square root of b. And then ratio, if they say it's the ratio of two things, like a is proportional to the ratio of b and c, well, you would just write that ratio there. So this is all kind of hopefully math words you've heard or seen before, but we want to make sure that we've talked about them at least briefly here. If you're unclear about any of these words, let me know and we'll talk about it kind of one-on-one. So our first example, a bird gains weight, W, at a rate inversely proportional to its age, T. Write the differential equation to describe this. So we're talking about gaining weight. So that means the rate in this case is W. So our derivative of weight with respect to, well, if it's a rate of weight, then we're going to expect it with time. And they say it's inversely proportional to its age. So that means we expect to see some constant over time t. So this would be our differential equation. We set the rate. So they said it gains weight at a rate, so we knew that weight was the thing we wanted our derivative of. So dw divided by dt, we kind of know that if you don't see something that specifically defines what we're taking the derivative with respect to, you can assume it's time. So we found the derivative with respect to time, and they said it's inversely proportional to its age t. So that means t needs to go in the denominator. And we have some constant in the numerator, and that's where we get this expression here. For our second example, the fraction of people P that hear a rumor increases at a rate proportional to the fraction of the population that haven't yet heard the rumor. Write a differential equation to describe this. So we know that we're trying to find the derivative of P with respect to time. And we know that that's a rate proportional to the fraction of the population that haven't heard the rumor yet. So we're going to get some constant, and we want to find how many people haven't heard the rumor. Well, they told us this was a fraction of the people P. So we know that P plus, we'll say, N for the number of people that haven't heard the rumor, those have to add up to 1 because they're both fractions. They're, percentages. So in other words, 1 minus P is going to be equal to N. And that's the number of people that haven't yet heard the rumor. And so this is where we get this expression here. it's proportional to the fraction of people that haven't heard the rumor. What's the fraction of people that haven't heard the rumor? 1 minus p multiplied by k, because it's proportional and we don't know exactly, if it's twice as fast, half as fast. All that we know is that they're proportional. And that's where we get this result here.